So I'm going to talk about JavaScript on mobile devices. What's the difference between a mobile application and a mobile web version? An example of a mobile application is Twitter for Android or Twitter for iPhone, whereas an example of a mobile web version is when you open a browser on your phone and navigate to mobile.twitter.com. The difference between these two arises from different expectations of the user. You do not expect native performance when you're browsing mobile.twitter.com, nor a native UI, whereas you do expect native performance and a native UI when you're using Twitter for Android and Twitter for iPhone. This presentation is going to be about JavaScript used in HTML5 mobile apps. My personal experience was with Adobe PhoneGap, but everything should apply to other frameworks. JavaScript for mobile devices. So why is it really different from the web? We've seen from the previous example that we are using JavaScript to compete with native performance that the user is expecting. That's challenging. And it gets tougher because of the limited amount of memory we have on mobile devices. Performance and touch events. Those are the two main pitfalls for HTML5 mobile applications. But how can you avoid these pitfalls? We have to use the correct libraries. We have to correctly handle touch events, optimize the app structure, optimize the code structure, and finally follow best practices. I'm going to talk about all these steps in the following slides. Let's start by using the correct libraries. So current JavaScript libraries hate mobile. They are very big libraries that were based on desktop requirements. So mobile performance isn't optimal, and they don't even support touch events. Let's take a look at the most common JavaScript libraries we have for the web. We have jQuery 2.0, which weighs around 81 kilobytes. It is used everywhere. Everyone knows its API, but the problem is it doesn't have touch support. jQuery 2.0 was built with desktop requirements. Thus its huge size. We have a lightweight alternative, which is Zepto.js, which weighs around 29 kilobytes. It delivers the same jQuery API, and it does have touch support. So we can clearly see that Zepto is a very good lightweight alternative to jQuery when we want to use it for mobile applications. And we also have the relatively new JavaScript frameworks such as Code.js. It weighs around 20 kilobytes, and it does have touch support. But the trick here, we don't always have to use a library. Let's say your application doesn't have DOM manipulation, nor Ajax, nor this stuff. You don't have to use a JavaScript framework, but don't reinvent the wheel. If you have to use it, use it. Okay, and there's something pretty cool about Zepto. It does support custom builds. Let me show you what are custom builds. Derek? عاملين سبليت سكرين او اكستاند مود او شو بدي افتح بس ما عم تنقل او بدي يمكن انزله اوكي ماشي هيدي هي الفول سكرين اكيد اوكي بس كيف بدي استعمل بس بدي ما في شوفها اثنين فينا نغير التايتل ريبورت. Okay, so I navigated to zepto.js.com, going to the download section, then the GitHub project. We can clearly see that Zepto is formed by several modules. We have the main module, we have the events module, the detection library module, the animation functions, animation functions, Ajax, forms, and we have the touch module. So I can create my own version of Zepto by including only the necessary modules. Let's say I'll use the core module, the events, Ajax forms, and the touch event, the touch module. And that way I'll have a lightweight في حطه duplicate. Displays, I think. حط start displays. مش okay. Thanks. So custom builds are a good example in order to keep the library of minimum size. Next, handling touch events. Click events are for the web. If you have any web application and you build it using PhoneGap or any other framework that builds your application into a web view, you'll notice that every click event will be delayed by 300 milliseconds. This delay has been introduced in order for the operating system to detect double taps, zoom in, zoom out, rotate, or other gestures without accidentally activating any page element. But this affects the user experience in a very bad way. So how can we solve it? We have to use the tap event. So click events are for the web, tap events are for mobile. Another problem pops up. JavaScript tap event is not natively supported. So we have to use a JavaScript library with touch support and use its tap event, or we have to use the noClickDelay.js project on GitHub. And then we have a new problem that arises. How can we test applications on our development machines that do not have touchscreens? So we're going to open Chrome, Google Chrome, open the developer tools. You open it with F12. Okay, and in the settings, go to overrides, and I'm going to emulate touch events. When I click on emulate touch events, every click will be, the mouse, when you click on the mouse, it will be considered as a tap event. That way you can transform your computer into a testing device. App structure. Should the app structure be a single page app or a non-single page app? There is really no definitive answer here, but I'm going to tell you why we decided to go with non-single page app for an application such as eTobb. We know that heavy JavaScript blocks the UI, so we always have to keep JavaScript minimal on each page. And DOM manipulation are costly on mobile, mainly because of the repaint and reflow. Repaint and reflow are all the calculations that determine the geometry of every element and its position in the page. So if we wanted to do a single page app, we'll have to include all the JavaScript in one file. So we're not keeping JavaScript minimal. That's why we chose non-single page app. And each page will have only the necessary amount of JavaScript included. And if we were going to do it in a single page app, the whole DOM manipulation will be in the main placeholder containing other pages. So that's also bad because of the limited amount of memory on mobile devices. I'm going to show you an example of code after the next slide. So the code structure we're following also keeps JavaScript minimal on all the pages. Let me show you how. So I'm going to create index.html. then register.html, a JavaScript folder containing index.js, register.js, and finally common.js. The trick here is to include all the common JavaScript in the common.js file, whereas only the required functions for index will be in the index file. Let me show you the code. So in this index.html page, we include the libraries up to. We include the common.javascript file, which is common for all the files, and the current page.js file, which is index.js. Now, what will all these JavaScript files contain? Notice how I used the on tab instead of the on click for the mobile, knowing that we have Zepto included. So here we have a global variable JS page, which tells us in which page we are. We have the login function, and on document ready, we are adding an event listener on the login button to call the login function. And finally, we have an event listener on device ready. This is specific for PhoneGap to hide the splash screen. Now you might see that hide splash screen function is not defined in this file. That's because we're using it in many files. So I'll define it in the common.js file. Okay, and finally, I'm going to wrap all the code in an immediately invoked function expression, the one that Jad Jabbour talked to you about. That way, after the function is executed, all the variables will be cleaned by the garbage collector. We only have JavaScript page, JS page, which is a global function, global variable. Okay, and now I'm going to start by showing you some best practices. So this is the page. I'm going to write text here, and I want the cars lane to update. For example, I write 3 characters. It should tell me 3 under it. On mobile devices. So I'm going to open the developer tools again and check its performance. We'll see that we might get a memory leak. We started at 2.7, this is 2.7 megabytes. Sorry. So it's 2.1 megabytes. I'm going to start writing. It's 2.7 megabytes, 3 megabytes, and then Google Chrome cuts it. Okay, so we do have one or more or several memory leaks here. Can anyone check the code and tell me how can we fix it? You know it. Anyone? True. Rakan, true. Okay. We have an anonymous function here, function. So on each key press event, an anonymous function is created and destroyed. That's really bad. So we have to define the function once. I'll define it outside. And name it handle key press. And then we're calling the function here, we're not defining it. So imagine the key press event is triggered every time you press on a key. So I pressed here on 109 keys. I created and destroyed the functions at least 109 times. I think it's 218 times, times 2. So, anything else? We have to manipulate the DOM. We're doing a DOM selector every time. So every time handle key press is called, we are doing a get element by ID on cars LAN. So why not cache it outside? Okay, now we might think that it got really better, but I'll show you that it's almost the same. Although the things that Rakan said are true. We'll still end up with a memory leak. .1 megs, 2.7, 3 megs, 3.2. Okay, so the problem here, what we did was correct, but there's another problem that Zepto and jQuery, their HTML and val function contains memory leak. So if we want to do it the best way, we have to eliminate Zepto, or at least not use the .html here and the .val. I'm going to rewrite it using native JavaScript to show you the difference. Okay, it's working using native JavaScript. Let's check its performance. اوكي، شو الكمبيوتر؟ الميموري عم تطلع وتنزل. اوكي. Okay, we're starting again at 2.1 megs. 2.2. Okay, I'm going to write 2.3, 2.4. Can you see the number? 2.2 and 2.4. So it's way better. 2.5. Okay. So we didn't eliminate all the memory leaks, but we made it like 2-3 megs better. So that was one of the best practices. I'm going to show you the other one, which is way more interesting. Also, before I want to show you the videos I forgot to show you before. Remember the click events? Click event. عندك VLC? Uh, rotate, image crop, colors, geometry, transform. Okay, this is a mobile application I did with only a click handler instead of tab. I wanted you to see the delay, the 300 milliseconds delay. So I clicked it, it waited 300 milliseconds for the event to fire. Once again. Okay, now I'm going to show you the same exact code, but instead of using click, I used the tap event. So it's totally different, okay? Using click will really make your user experience very bad. So it's very good to pay attention to it. Okay, next up, animations. This is with no CSS. I'm going to add some style sheets and some CSS in order to do the left drawer animation. You all know in Facebook app when you open the chat or the settings. Okay, this is it. The green button, I want when I open the green button for the left drawer to push the main container. I'll do it using JavaScript animation at first. Okay, so this won't work because I put tab. I need to go again to Chrome Developer Tools and emulate touch. Okay, we're emulating touches. Wait. Okay. So this is the animation. Okay, it looks pretty fine. Let's put it on mobile and let me show you a video how it looks on mobile devices. Can you all see that the animation is very sloppy? It's very slow. It's clear. Okay. So the rule of thumb here, never use JavaScript for animations on mobile. What can we use instead? Does anyone know any other alternative? CSS3. Okay. Transforms, keyframes, transitions. Sure. Okay, I'm going to rewrite the animation part using CSS3. Actually, not only CSS3, hardware accelerated CSS3.
All browsers support CSS3 right
If you're going to do a mobile application for Android and iPhone, it's WebKit, so you can use it. Even Gingerbread 2.3 supports it. And Internet Explorer 9, 10, 11 do support. Chrome and Firefox, of course, they do. 10? يمكن 9 doesn't support. You may now kiss the bride. CSS3 v1. It works. We won't be able to see any difference on the desktop. But I'll improve it in two ways. First thing, I'm not going to use the left because left triggers the browser reflow and repaint I talked about. We're going to use WebKit transition. WebKit transform and translate X. Translate X moves the position of the current element without recalculating anything. It still works, still no apparent changes. I'm also going to force hardware acceleration. Forcing hardware acceleration will make the animation much smoother. Does anyone know why this line forces hardware acceleration? WebKit transform translate 3D 0, 0, 0. True. So here we're tricking the browser. We're telling him we're going to do some 3D animations. Yeah, when it thinks it's going to use 3D, it enables hardware acceleration. But we didn't change anything, so because we used translate 3D 0, 0, 0. We're still on the origin of the XYZ plane. Okay, now let me show you how this performs on mobile. CSS3 animations versus the JavaScript one. Yeah, you have to know how to enable it. So check here the code. It drains the battery, but yeah, not in this way. I enabled it on the class of the animation. If you enable it on the main container, all the elements will be hardware accelerated, and it might really be very bad. It's smooth. Round two. So that's it. Any questions? That's everything for tonight. My files will be available on GitHub along the presentation. Any questions?
What was the biggest challenge you faced when building the web from both Android and iPhone? And it's super Vodafone gap build once deploy for all. But what was the biggest challenge for deploying Android and iPhone using one code base technique?
It wasn't the same code base. We used the same backend, which is the JavaScript functions. You mean it was the main pitfalls, performance and touch events. Is that what you mean? It is performance and touch events. We spend days optimizing the code using JavaScript sometimes instead of Zepto, even optimizing CSS, HTML, everything. We performed the هيدا performance شو اسمه تبع Chrome developer tools on all the application. We were seeing where are the bottlenecks so we can fix them. And we tested on all devices. That was really important. Like Samsung Galaxy S2, S1.
You gave an example where lowest performance. And where was
Versus native JavaScript.
versus native?
It wasn't the DOM selection part. It was the .html function and the .val. It was creating memory leaks. And the same for jQuery.
Okay, so where would you include Zepto? Is it only for the touch capability?
No, I would use Zepto everywhere, even the .html and the .val, but here it was a critical case. يعني الهاندل كي بريس بيتعيط له بالثانية شي 5 مرات إذا واحد عم يكتب.
But when you removed it out of the function,
Yeah.
then you use regular native JavaScript, it improves the performance even more.
Exactly, because handle key press بيتعيط له حوالي 100 200 مرة. يعني إذا عندك 5 مرات، إذا عندك 5 دوت فال دوت 10 20 ما بيعملوا مشكلة. هون لأنه هي ذاتها الهاندل كي بريس هي بحد ذاتها كان فيها ميموري ليك. 100%. وكيف تعرف شو هن هودي البوتل نكس؟ بدك تعمل البرفورمانس، تفتح الجوجل ديفلوبر تولز وتشوف وين المشكلة فيها. Anything else? Okay.